Hello and welcome. So let's begin with Python data structures. As we discussed in the previous video, the first data structure that we are going to discuss is Python list. So as in, we have Python list and arrays, which is a built-in data structure that serves as a dynamic array. Lists are ordered, mutable, and can contain elements of different types. Mutable and or heterogeneous elements. And lists as in arrays used by many algorithms for solving the problems. So, how do we create a list? Let us see. First, we will see how do we create an empty list. Suppose we have to create a list named A. So, empty list can be created with empty square brackets. And if I want to initialize with values, suppose I will want to create a list of numbers. I can create 0, 1, comma 2, comma 3, comma 4, comma 5. And if I want to create a list with different type of data, so I can create one number, one string, and I can even create with one floating point number, and we have boolean and so on. So this is the way we can create a list with heterogeneous elements. So you can try creating and printing the values like we have defined here. And let's see the important methods that we work with lists. So Python lists come with several built-in algorithms called as methods. So to perform common operations like appending, sorting, merging, and many more, we have several built-in methods for list. For example, if I have a list of numbers, I have a list of numbers, say 5 elements, and first method I work with list is append. So how do I append? If I want to append 1, 2, 3, 4, 5 is the values within the list X. I wanted to add, append one more element at the end 6, then I can append X. Simply I can call append. It is a number, so I will just give as 6, and its output is, if I print X, it will have to output after X dot append 6. It has to print 1, 2, 3, 4, 5, and 6. It just adds the appended value at the end of the list like this. So if the numbers are not in an order, like if I have another list Y, which is 12, 6, 8 and 13. So if I wanted to sort the elements within a y, then I can simply do y dot sort. It must print y dot sort will print the order from smallest to the highest value in the list, like this. So we have seen append and sort. These are basic methods that we work in list. There are so many other methods we will look into in the further lessons. And let's quickly look up a basic working of algorithm. So let me start with a basic operation with algorithm. Example for algorithm implementation with data structure. So like we had sort and append, these are all built-in methods. If I do not have certain operation available as a built-in function, what I can do, I can create my own steps as in algorithm, and then I can implement it as a method, which is user defined method, instead of using built-in methods like append and sort. So I have a sample case that I need to find the lowest and highest value in the list. So we don't have a ready-made method. Assume we don't have it, and let's start writing step by step. Assume array has elements 8, 12, 9, 3, 10 and 6. So if I have to fetch the minimum value and maximum value, which is the highest and lowest values, I need to write step by step to achieve this particular result. So let me start with a simple program. So I have the array, and for I in array, if I less than, I have to fetch the first element. Let me consider min is equal to array of 0. So then let me think, like if I less than min value, then I can assign that min value to I. Likewise, I can even define max, or I can even simply give min equal to max equal to or if 0. And in this step, what I can do, if I greater than max, then simply max equal to I. And in the end, we will display the min and max values. Lowest is min, and highest is max. So this has to get min and max of the given array. This is how we will solve our problem to write an algorithm to find the solution. So this is one of the sample for example. And it is very basic and fast enough for smaller data sets. But if the data is big enough and any algorithm will take time to run, in that case we have to look into different algorithm which is best suitable for that particular solution. So then when we have huge data, we need to optimize the solution based on the data size and the problem. Optimization is important while doing algorithmic development, and it is a part of DSA programming as well. And one more important thing is time complexity. When exploring algorithms, we often look at how much time an algorithm takes to run based on the size of the dataset. As in the above example, the time the algorithm needed to run the linear list of data is depending on the size of the dataset. And algorithm must visit every array element one time to find the lowest value and the highest value. The loop must run the number of elements within the input array list. So if it has 6 elements, it will traverse through the list 6 times. It has 1000, it will have to loop around 1000. So if we compare the operations needed to find the lowest value and highest value and the size of the array, we can compare its runtime with number of values. So it depends on the size and it takes the time depending on the elements in the list. So let's discuss more further about other type of data structures in the next lesson. Thank you for watching.